everyone. My name is Edward Perea, and I'm going to be talking about the Apache drill data collection and analysis project. So the main motive behind this project was to drill and measure the geomechanical properties of core at the Edgar mine. And this would enable us to then use machine learning and train the data so that it would be able to characterize the different geomechanics from drilling data via a neural network. And this would help with the overall autonomy of drilling, whether it be oil and gas, geothermal energy, and even space resources exploration. And there would be less of a need for instrumentation, logging needs, and it would optimize the overall drilling performance. So here we have a picture of us down at the Edgar mine. This is the Apache horizontal drilling rig, which was hydraulically powered by a triplex motor system. Here are some of the core that we extracted from the mine. Here we have 3 examples. This is the first one, looks like it's hornblende. The second one's biotite, and the third one's also hornblende. And so this core was it wasn't originally like this. It was taken to the core prep lab, and it was cut with a saw until it was about 6 to 8 millimeters in length. And then these cores were then photographed, measured, weighed, and inserted into the MTS press. And what the MTS press is that it would press on them until they failed. And here we have a really quick video to show what that process looked like. There you go. So what the MTS press does is that it would measure the displacement as well as the force, and that enabled us to be able to calculate the stress and strain, and that's what we have here. And what we did is that we categorized all the different cores into a number of different rock types. I worked with predominantly 4 rock types, number 1 being biotite, 2 being quartz plagioclast gneiss, number 3 being hornblende, and the last one being biotite, microcline pegmatite. And here we have the stress and strain relationship for all 4 of them. So the first one's biotite, second one's quartz plagioclast gneiss. We have 3, and then we have 4. And then lastly, we did a statistical analysis on a number of different things. For example, we did the density, we did Young's modulus, we did the uniaxial compressive strength, as well as the uniaxial compressive strength for failure due to natural fractures. So here we have the minimum density for biotite was 2.712, and then the max density for hornblende was about 2.835. And usually some sources of error is that when we were actually trying to determine the UCS, being the uniaxial compressive strength, we don't want to use the data that where the cores fell due to their natural fractures, just because the UCS that we're measuring is the strength of the fracture itself rather than the grains of the rock. So those would be discarded. And using all this geomechanical data, we would then be able to use machine learning, train AI with the drilling data, and create a neural network so that it could characterize the geomechanics properties of the rock. Thank you very much.